fourth problem, it is given that 270 degrees is less than theta is less than 360 degrees. By dividing throughout by 2, 135 degrees is less than theta by 2 is less than 180. So hence theta by 2 lies in the second quadrant, and hence the value of tan theta by 2 must be negative. Now tan theta by 2 is equal to, we have to take the negative value, therefore minus of square root of 1 minus cos theta by 1 plus cos theta. Therefore this is equal to minus square root of 1 minus 1 by 4, 1 plus 1 by 4. After taking LCM, this is equal to minus of square root of 3 by 5. So 270 is less than theta is less than 360 is given. Dividing by 2, we'll get 135 degrees less than theta by 2 less than 180. Thereby we know that theta by 2 is in the second quadrant, where tan theta by 2 should be negative. Therefore tan theta by 2 is equal to minus of square root of 1 minus cos theta by 1 plus cos theta. It is equal to minus of square root of 1 minus 1 by 4 plus 1 plus 1 by 4. In the numerator 4 is the LCM and here is 4 LCM. Therefore after taking the LCM, the remaining value is root 3 by 5. So therefore it is minus of square root of 3 by 5. Next problem. Modulus tan A is equal to 12 by 5. 630 is less than A is less than 720. So A lies in the fourth quadrant and the value of tan A must be negative. It is given that modulus tan A equal to 12 by 5. Therefore tan A is equal to minus 12 by 5. Now secant A is equal to secant in the fourth quadrant is positive. So therefore we have to take the positive value of root of 1 plus tan square A. This is equal to square root of 1 plus 144 by 25. Therefore secant A is equal to 169 by 25, which is 13 by 5. Hence cos A is equal to 5 by 13. So modulus of tan A is equal to 12 by 5, and it is given that 630 degrees is less than A is less than 720. Hence tan A is in the fourth quadrant, and since the angle A is in the fourth quadrant tan A is negative, therefore tan A is equal to minus 12 by 5. And in the fourth quadrant secant is positive. Therefore secant A is equal to plus value of root of 1 plus tan square A, and it is square root of 1 plus 144 by 25. On taking LCM, it is root of 169 by 25 equal to 13 by 5. Therefore cos A equal to 5 by 13. Now we have to find sin A by 2, cos A by 2 and tan A by 2. Since 630 is less than, A is less than 720, by dividing throughout by 2. So it is 315 degrees less than a by 2 less than 360 degrees. So therefore a by 2 is also in the fourth quadrant. Now sin a by 2. In the fourth quadrant, sin a by 2 is negative. Therefore, we have to take the negative value of root of 1 minus cos a by 2. Because sin a by 2 is equal to square root of 1 minus cos a whole by 2. So this is equal to minus square root of 1 minus cos a is 5 by 13 by 2. So on taking LCM, this is equal to 13 minus 5. It is 8 by 26. 2 gets cancelled, therefore this is minus 2 by root 13. Next, cos a by 2. This is angle a by 2 is in the fourth quadrant where cos a by 2 is positive. So therefore this is equal to positive value of square root of 1 plus cos a by 2. That is square root of 1 plus the value of cos a is 5 by 13 by 2 is equal to square root of 18 by 26, and 2 gets cancelled, it is 3 by root 13. Therefore tan a by 2, here we have calculated sin a by 2 and cos a by 2. Therefore tan a by 2 is nothing but minus 2 by root 13 into root 13 by 3 equal to minus 2 by 3. If tan a by 2 is only asked, we will write it as tan a by 2 equal to square root of 1 minus cos a by 1 plus cos a, and we have to take the negative value because a by 2 is in the fourth quadrant. That means if these two are not asked to calculate, then tan a by 2 is equal to minus of square root of 1 minus cos a by 1 plus cos a. But here, since we are asked to calculate sin a by 2 and cos a by 2, directly tan a by 2 is equal to sin a by 2 by cos a by 2 means minus 2 by 3. So modulus of tan a is equal to 12 by 5. And it is given that 630 is less than a is less than 720, which means a is in the fourth quadrant. Therefore tan a is equal to minus 12 by 5. Secant a is positive in the fourth quadrant. Therefore secant a equal to positive value of root of 1 plus tan square a equal to root of 1 plus 144 by 25, which is equal to 13 by 5. Therefore cos a is equal to 5 by 13. Now 630 is less than a is less than 720. By dividing 2, 315 is less than a by 2 is less than 360. That means a by 2 is also in the fourth quadrant. In the fourth quadrant, sin is negative. Therefore sin a by 2 equal to minus of square root of 1 minus cos a by 2. That is equal to minus of square root of 1 minus 5 by 13 by 2. After taking LCM, 13 minus 5 becomes 8 by 26. 2 gets cancelled, and square root of 4 means 2. Therefore it is equal to minus 2 by root 13. Now cos a by 2. A by 2 is in the fourth quadrant where cos a by 2 is positive. Therefore cos a by 2 equal to square root of 1 plus cos a whole by 2 equal to square root of 1 plus 5 by 13 by 2, which is equal to square root of 18 by 26, and after cancelling 2, here 9 will be left. That means square root of 9 means 3. Therefore this is 3 by root 13. And tan a by 2 is equal to sin a by 2 by cos a by 2 is equal to minus 2 by 3. Sixth problem, first bit. LHS equal to 1 by sine 10 degrees minus root 3 by cos 10 degrees. Two into 1 by 2 by sine 10 minus root 3 by 2 by cos 10 degrees. Outside we are multiplying by 2 and inside we are dividing by 2. Therefore, the value does not change. So therefore, 1 by sine 10 minus root 3 by cos 10 can be written as 2 into 1 by 2 by sine 10 minus root 3 by 2 by cos 10. And 1 by 2 can be written as sine 30 because the denominator is sine. We will write this in terms of sine, and this we will write in terms of cos. So therefore, this is equal to 2 into sine 30 by sine 10 minus cos 30 by cos 10. Now we can take the LCM. Therefore, this is equal to 2 into the LCM is sine 10 into cos 10. In the numerator, we will get sine 30 into cos 10 minus cos 30 into sine 10 degrees. This is equal to 2 into. In the numerator, it is in the form sin A cos B minus cos A sin B, which means sin A minus B. So it is sin A is 30 and B is 10, A minus B means 20 degrees by sin 10 degrees cos 10 degrees. And this is equal to 2 into sin 20 degrees can be written as 2 sin 10 into cos 10. 2 sin 10 degrees into cos 10 degrees whole by sin 10 degrees into cos 10 degrees. These two gets cancelled and the answer is 4. Here sin 2 theta is equal to 2 sin theta cos theta. According to that, sin 20 can be written as 2 sin 10 into cos 10. So the given problem for which the LHS is 1 by sin 10 minus root 3 by cos 10. Outside we are multiplying by 2 and inside we are dividing by 2. So therefore this is 2 into 1 by 2 by sin 10 minus root 3 by 2 by cos 10. Sin 30 is 1 by 2, therefore 1 by 2 is written as sin 30 and root 3 by 2 is written as cos 30. Therefore this is equal to 2 into sin 30 by sin 10 minus cos 30 by cos 10. And after taking LCM, sin 10 cos 10, in the numerator we will get sin 30 cos 10 minus cos 30 sin 10. Sin A cos B minus cos A sin B. It is equal to sin A minus B. A is 30 and B is 10. A minus B means 20. Therefore, it is equal to 2 into sin 20 by sin 10 into cos 10. But sin 2 theta equal to 2 sin theta cos theta. According to that, this is 2 sin 10 cos 10. Sin 10 cos 10 gets cancelled. 2 into 2 becomes 4. Second bit, cos 100 into cos 40 plus sin 100 into sine 40 is equal. So we have to find the value of cos 100 cos 40 plus sine 100 sine 40. This is in the form cos A cos B plus sine A sine B. Cos A cos B plus sine A sine B is equal to cos A minus B. So therefore this is cos A means 100 minus 40. So therefore this is cos 60 and it is equal to 1 by 2. So cos 100 into cos 40 plus sine 100 into sine 40. Cos A cos B plus sine A sine B is cos A minus B. That means cos 100 minus 40 equal to cos 60 equal to 1 by 2. Now the next problem. Square root of 2 plus square root of 2 into 1 plus cos 4 theta. Equal to square root of 2 into 1 plus cos 4 theta is 2 cos square 2 theta. Now this is 2 into 2, 4 cos square 2 theta. When this root is applied, it becomes 2 cos 2 theta. So therefore this is equal to square root of 2 plus 2 cos 2 theta. And here we can take 2 as common factor. This is 1 plus cos 2 theta. So therefore this is equal to square root of 2 into 1 plus cos 2 theta is 2 cos square theta. So therefore this is equal to 2 cos theta, since it is given that theta is less than pi by 4. So square root of 2 plus square root of 2 into 1 plus cos 4 theta. That is equal to square root of 2 plus square root of 2 into 1 plus cos 4 theta is 2 cos square 2 theta. 2 into 2, 4. 4 cos square 2 theta. When this root is applied, we will get 2 cos 2 theta. On taking 2 as common factor, inside we will get 1 plus cos 2 theta. 1 plus cos 2 theta is 2 cos square theta. Once again, this is 4 cos square theta under root. It is equal to 2 cos theta, since theta is less than pi by 4 and greater than 0. That means it lies in the first quadrant. Eighth one. First one is given as f of x equal to cos of 4x plus 7 by 5. We are asked to find the period for this function. The period of cos theta is 2 pi. This is cos of 4x plus 7 by 5. That means it is cos of 4 by 5 into x plus 7 by 5. The coefficient of x is 4 by 5 and the original period of cos is 2 pi. Therefore, period of f of x is equal to original period is 2 pi by 4 by 5. So this is 2 gets cancelled here. So therefore it is 5 pi by 2. So the period of sin theta or cos theta is 2 pi and the period of tan theta is pi. And f of x is equal to cos of 4x plus 7 by 5. The coefficient of x is 4 by 5 and the original period of cos is 2 pi. Therefore, the required period is 2 pi by 4 by 5, which is equal to 5 pi by 2. Second one, f of x is equal to cosecant 6 minus 5x. the coefficient of x is minus 5 and the absolute value of the coefficient of x is 5. We want only the absolute value of the coefficient of x, and the period for sine is 2 pi and the period of cosecant is also 2 pi. Therefore, f of x is equal to 2 pi by modulus of minus 5, or directly you can take only the absolute value and write 2 pi by 5. So f of x is equal to cosecant 6 minus 5x, period of f of x is equal to 2 pi by modulus of minus 5. It is equal to 2 pi by 5. Third one, f of x is equal to sine of x plus 3x plus 5x. This is equal to 5 plus 3, 8 plus 1, 9, sine of 9x. And the period of sine x is 2 pi. So period of f of x is equal to, the original period of sine is 2 pi and here the coefficient is 9, therefore the required period is 2 pi by 9. Sine of x plus 3x plus 5x equal to sine of 9x. The period of sine is 2 pi, but here the coefficient of x is 9. Therefore, period of f of x is equal to 2 pi by 9. Third one, f of x is equal to sine of x plus 3x plus 5x. This is equal to 5 plus 3, 8 plus 1, 9, sine of 9x. And the period of sine x is 2 pi. So period of f of x is equal to, the original period of sine is 2 pi and here the coefficient is 9, therefore the required period is 2 pi by 9. Sine of x plus 3x plus 5x equal to sine of 9x. The period of sine is 2 pi, but here the coefficient of x is 9. Therefore, period of f of x is equal to 2 pi by 9. Fourth one, f of x is equal to sine square x plus 2 cos square x. This is equal to sine square x plus cos square x plus cos square x. Sine square x plus cos square x is 1 plus cos square x. To find the periodicity of any trigonometric function, square must not be there. This must be changed into multiple. 1 plus cos 2x is equal to 2 cos square x. Therefore, this is equal to 1 plus cos square x is nothing but 1 plus cos 2x whole by 2. This 1 and 1 by 2 cannot affect the period. The coefficient of x is only necessary. Coefficient of the angle x is 2 and the period of cos is 2 pi. Hence, required period is, so period of f of x is equal to, originally the period for cosine function is 2 pi, and since the multiple of x is 2, it is 2 pi by 2, hence it is equal to pi. So the given problem, sine square x plus 2 cos square x is written as sine square x plus cos square x plus cos square x, which is equal to 1 plus cos square x. cos square x can be written as 1 plus cos 2x whole by 2 according to this formula. Now, the square is removed and the angle is expressed in terms of multiple. So, therefore, originally the period of cosine is 2 pi and here the coefficient of x is 2. Therefore, it is 2 pi by 2 equal to pi. So, the main important point is to find the periodicity of any trigonometric function. Angle must be expressed in terms of multiples of something, but square should not be there. Now, the fifth problem, f of x is equal to tan of x plus 2x plus 3x and so on up to nx. This is equal to tan of, let us take x as common, it is 1 plus 2 plus 3 and so on up to n. Therefore, this is tan of, this value is n into n plus 1 by 2 into x. Sum of first n natural numbers, n into n plus 1 by 2. So, therefore, the given problem is tan of n into n plus 1 by 2 into x. And for a tan function, the period is pi. Therefore, period of f of x is equal to pi by n into n plus 1 by 2 is equal to 2 pi by n into n plus 1. So, the given trigonometric function is tan of x plus 2x plus 3x and so on up to nx. X is taken as common factor. Inside we got 1 plus 2 plus 3 and so on up to n, and its value is n into n plus 1 by 2. Therefore, the given function becomes tan of n into n plus 1 by 2 into x. And for a tan function, the period is pi, and here the coefficient of x is n into n plus 1 by 2. Therefore, the required period is pi by n into n plus 1 by 2, which is equal to 2 pi by n into n plus 1. Next problem, f of x is equal to modulus of sin x. The period of a sine function is 2 pi, but here it is modulus sin x, so hence its period is only pi. Period of f of x is pi, since f of pi plus x is equal to modulus of sin pi plus x is equal to modulus of minus sin x. Modulus is always positive, therefore it is modulus of sin x. So, therefore, the period of modulus of sin x is only pi. Unless otherwise asked, this need not be done. This is only for the student to know it. Cosine function with period seven is equal to, we cosine function, therefore it is cos, and the period any cosine function is 2 pi, but here the period must be 7. So, therefore, it is 2 pi by 7 into x. Here plus or minus can be written, but cos of plus theta or cos of minus theta both are same, hence it is not written. Even if we write this as cos of plus or minus 2 pi by 7 into x, the answer is same. So we are asked to find a cosine function with period 7. For any cosine function, the period is 2 pi, but here we require a cosine function with period 7. So therefore it is cos of 2 pi by 7 into x, or this is also equal to cos of plus or minus 2 pi by 7 into x. In the beginning, minus is not written because cos of minus theta is also equal to cos theta. Function with the period two by 3 is equal to sine. The period of any sine function is 2 pi, but for the required function the period is 2 by 3. So therefore it is sine of plus or minus 2 pi by 2 by 3. So this is equal to sine of plus or minus 3 pi into some x or theta or anything. So sine function with period 2 by 3. For any sine function the period is 2 pi, but for our required function the period must be 2 by 3. Therefore the sine function is sine of plus or minus 2 pi by 2 by 3 into x, that is sine of plus or minus 3 pi x.